Okay, in this example, we have that pollsters are concerned about declining levels of cooperation among persons contacted in surveys. A pollster collects 73 people in the age group of 18 to 21, and then finds that 62 of them respond and 11 refuse to respond. And then 267 people are in the 22 to 29 age bracket that are contacted. 251 respond and 16 do not. Assume that 1 out of the 340 people is randomly selected. We're going to find the probability that getting someone in the age of 18 to 21 age bracket or someone who responds. So that is a lot of information thrown at you at once. And when you read that the first time, your brain is probably hurting. So what I suggest that you do is when you read a math problem, it's not like when you read a novel or a magazine where you just read it once and usually you just get it. You just read through it and you comprehend it. When you read math, it's a completely different animal. You have to approach it differently. And this is what I tell all my students. The first time you read through it, you just want to get the general sense of what is going on in the situation. So this is just a situation where someone's making a survey in different age brackets. So that's what I got from it the first time I read it. There is no way you're going to be able to absorb all the information that was given to you in one read. What you want to do once you get the general sense of what's going on, then you want to do a second pass through and pick out the major pieces of information that you think you need and organize it. Sometimes you want to organize it in a graph, sometimes in a table, sometimes just jotting it down on the side of your paper. In this case, it actually gives you a hint in the problem to organize it in a table first. And usually with probability, you will organize it in a table because usually with probability, your strategy of finding the probability is taking the number of outcomes in the event that you're looking for out of the total number. So organizing it in the chart with all the totals in the different categories is usually the way to go to organize it when you're dealing with probability. So even if they don't give you the hint, that would be what I suggest that you do. So it doesn't really matter how you organize your chart. If you put something in rows, columns, it doesn't matter. As long as what the information that you put in there is correct, then you're good to go. Okay, so we're going to make we actually have, I should say, 4 categories. We have 2 age groups, and then we have 2 categories where they respond or they don't respond. So up at the top here, I'm going to put respond and then doesn't respond. And then over here, I'll put the age group. So we have an age group that's 18 to 21, and then we have another age group that is 22 to 29. Like I said, it doesn't matter if you put the age groups across the top and the responder doesn't respond along by the rows. It doesn't matter as long as it's correct. And then we'll put the totals here. Whoops, I need one more row down here. Let's see, insert row below, total. Okay, now let's pick out the information from the problem to help us figure this out. All right, so the big information that's given to us, we have that 73 people were contacted in the age bracket 18 to 21. So the total for that age group was 73. Okay, now we also have 62 of those respond and 11 don't. So I'm going to put 62 respond and 11 don't. And when I check the 62 and 11, that gives me 73. So you just check as you go along to make sure what you're doing makes sense. Then the next one says there were 267 people in the 22 to 29 age bracket. So let's put that here, 267. And let's see, 251 responded and 16 refused. So I'm going to put 251. Sorry, it's a little messy. I'm trying to write with my mouse. and then I have 16 that didn't respond. Okay, now if I come across here, I can make sure that they add up. So if I take 251 and 251 and 16, that gives me 267. So that works. Now I can make, even though they didn't give us this information, I can come down and give the total for doesn't respond and respond. So when I take 11 and 16, that gives me 27. When I take 62 and 251, that gives me 313. And then if I add across this way to get the total of everybody in the sample, if I add this way in the column or across this way in the row, it should still add up to the same thing, which is 340. And we can check that by doing it both ways, but then we can also see, which is nice, that they give us that information in the problem here where it says that one of the 340 people are selected. So there's all different ways that we can make sure that we're doing this correctly. So I would definitely suggest just double checking anything, the information that they give you. Now, it took a minute or two to fill out that table, but by doing that, it's really going to help us figure out how to rewrite this problem. So let's see. We have to answer this as a percent. So we got to make sure that we put that in percent form at the end. And it says we want to find the probability that whoever we pick is going to be in that age group or is someone who responds. So we're going to do an addition problem here. And then we're going to subtract off any overlap. So I'm going to write the general formula down here. Remember, if you have the probability of A or B, again, sorry for the messy writing. I'm trying to write as neat as I can with this mouse. When you have an or statement, you have a probability of A, and then you add it to the probability of B, but sometimes if you don't have events that are mutually exclusive, you have an overlap where some people or some items in the sample are going to get counted twice. So for those, you have to subtract them off so they're not counted twice. So that's why in the general equation we have minus the probability of A and B. So wherever they overlap, we subtract them off so they're not counted twice. So that's what we're doing up here. I'm finding the probability of A, that's going to be this piece here, the probability of being in the age group 18 to 21. Then I'm going to find the second event, that probability, the probability of B, which in this case we're talking about the people that respond. And then if there's any overlap, we're going to subtract that off so that we don't count somebody more than once. Okay, so now I'm going to try to color coordinate this. The group of people that are in the 18 to 21 group, that's these people right here. And there's 73 people out of 340. So that's going to be the probability of picking someone in that age group. So 73 out of 340. That's the probability of picking someone in the age group 18 to 21. Now, I want to find what's the probability of picking someone that responds. So now I'm going to color coordinate. I'm doing this in this aqua blue color so you can see how this works. If the person responds, they're in this group here. So that's going to be a total of 313 out of 340. However, we just counted one of these groups in this table twice. It's where they overlap. When I counted the group that had the ages of 18 to 21, I counted this 62. But then when I counted the responding group, I counted that 62 again because I counted this way. So this is the group, that 62 out of the 340, that we counted twice when we counted this for the probability. So that's why we're subtracting off the overlap where they both happen, where A and B happens. In this case, it's where we have the age group of 18 to 21 and respondings. That's this group of 62. So I'm going to subtract 62 over 340. So now what I have to do is put that in on my calculator and find the answer. So let's see. It says we need to round this in the problem to 1 decimal place. So I'm going to put in on my calculator 73 divided by 340 plus, I'm going to add 313 divided by 340. And then I'm going to subtract off my overlap, which was the 62 over 340. Okay. Now by default, the calculator is going to give me the decimal value. The question asked us, if you notice here, because of that percent sign, we need to put it as a percent with 1 decimal place. So to put this into percent form, I'm going to multiply by 100, and then I'm going to round. So it's going to be 95.3%, because this 9 here is going to make the 2 bump up to a 3. So my final answer, when I put it in percent form, rounded to 1 decimal place, is 95.3%. Now, if it asked for the decimal value, I would just leave it as 0.953.